So how do you have gas pressure without a container? Nothing? Danny Faulkner, PhD astrophysicist, runs an observatory and profits from the lies.
So what we can see is we've got some gas and it's inside this container. Bear in mind that they tell us we live on an Earth that is infinitely in the vacuum of space, right? This would be the Earth's atmosphere that we're breathing, right? But it's got to be contained, which is our point, right? So let's make the volume bigger. And look what happens. As you make the volume bigger, you get to the limit of 1,000 litres, and you can see that the pressure is reduced. So let's bring this down. Watch the pressure going up, because you're reducing the volume. Now it gets to the maximum, like the smallest amount of volume, and the pressure's up. Yeah. So let's take it down to say halfway, roughly, and you can see that the pressure's changed as a function, right? If we agitate these, let's turn the heat up on them and agitate them. What it does is it pushes the volume out. That's what explosions are, right? As you add heat, it pushes out the volume because it's agitating the gas. And then if we remove the heat, it contracts. That's what happened with the magnesium test that I did. It contracted the volume. You can argue for why occurs. That's what it did. I'm not asked about the explanation. I'm interested in the cause and the effect. But we can see that if we add heat, it pushes the volume out. If we remove heat, it contracts. And you can see the effect. Each time we do it, you can see the effect. So add heat, and the pressure stays the same, but the volume increases. If we remove heat and make it cool, pressure stays the same, but the volume shrinks. So let's add some heat to put it back to the middle. This time we're going to add the gas. So now what we're going to do is we're going to open the valve. Oh, that's release. That's a pressure relief valve. That's pretty cool, isn't it? So you can relief valve off it, pressure off it, and then you can pump some more gas into it. Isn't that cool? So as we pump more into it, the volume increases, right? But we don't want, let's say we can fix the volume. So if we reduce the volume down a little bit and we fix it so that it doesn't move, and then we add add gas into it, you can see that there's more molecules, and you can see that the pressure's going up. This is what happens with your car tyre, yeah? Everybody understands this. So let's not lock that. The temperature, we can add heat. That's going to increase the volume until we stop it. But if we add heat and fix the volume, look at the pressure going up. So it's the interaction between the quantity of gas, the fixed volume or the variable volume, but the volume itself. The pressure is a function of the temperature, the volume, and the way this works. And this is the best way of demonstrating it. And this is all in a confine of a container. Now, I'm not able to demonstrate what happens when you get to be above the 1,000 litres, because obviously nobody thought they were going to be... You'd have to be a moron to think you could have gas pressure, but without a container. You need the container. So basically, go and play with this at this link. I'll put it in the description box. Go and play with this, and you can see how the interaction works, and it's really intuitive. By the way, we can let's take some of the heat off here, remove some of the heat. I just want to show you what happens when you put in a second gas. So there's one gas in there now, and if let's make the volume a little bit bigger so we can see the other gas going in. Pump in a little bit of gas from the other one, and you can see if the atmosphere that we live in has got several gases, so there's nitrogen, oxygen, all the gases that are in there, you can add more, you can see the interaction between the gases. So let's remove some of the heat and slow these down so we can see what's happening. It's a bit faster. And you can see that the way that they interact, the pressure is caused, as we know, by the force emitted off hitting the contact or the collisions with the container. Right? We can see this is happening. If there was no container there, the gas would fill the available volume, wouldn't it?
Let's try another pretty simple process. Let's just take a gas in some volume, V, and over here is going to be vacuum, V equal volume, and we're going to remove the barrier. You know what's going to happen spontaneously, right? The gas is going to fill the available volume once it becomes available, right? the gas is going to fill the available volume once it becomes available.
If it disagrees with experiment, it's wrong.